Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are going to identify functions. So take a look at the lesson today. List the order pairs shown in the mapping diagram. Then determine whether the relation is a function. So let's take a look at this input and the output at these two order sets. So the first input is 12. So we have 12 and the output is 6. So the first order pair is 12, 6. The second one, we have 23 for the input, 23, and the output is 15. Next one, we have 30 for the input and 20 for the output. And the last one, we have 48 and 13. 48 and 13. Please remember that for each input, there should be exactly one output. Mr. Dobrescu gave you an example about the vending machine, right? When you put that money in the door, you expect to get only one item. So let's check to see in the first example, if we have only for each input, there is exactly one output. Let's see, 12, 6, this checks, is good. 23 goes only to 15, this is good. 30 goes only to 20, this is good. And 48 goes only to 13, and this is also good, it checks. Which means that this relation is a function. This is a function. Let's continue to the second example to see if the second example is also a function. So the first input we have 10, so we have 10, and the output is 0. Now take a look at 10. 10 also goes here for the input, and then 10 also goes to 1. 10 goes to 1. And this is a red flag right away because 10 is a problem. There is one input, but then we have two outputs. And that's a no-no. Okay? We cross it out. Okay, let's continue. 11 goes to 0. That's great. One input, one output. Now let's take a look at 12. We have 12, 12 goes to 1 for the order pair, and also 12 goes to 3. 12 goes to 3. And 12 is also a red flag. 12 is also a problem because for each input there are two outputs, and that's a no-no. Okay? So that cannot happen. And then 13 goes to 2. That's okay. 13 and 2. But we can say about the second relation is not a function because 10 and 12, they have two outputs. So not a function. Not a function. Please remember for next week quiz, when you practice, you have to understand that if you get one input with two outputs, that's not a function. Remember that. Let's continue with the next set of order pairs. Okay, let's continue at this example here. We have input X and output Y. So the first order pair is 0, 0. Next one we have 2, 1. But also 2 goes to negative 2. So we have to be very, very careful because again, 2 has two outputs and that's not okay. So that's a problem. That's a red flag. And then 4 go to, so 2, negative 2, and then 4 go to negative 3. But we can say about this relation, this is not a function because we have a problem. 2 has two outputs, so not a function. Let's continue to the last one here. We have negative 9 and 0. So negative 9, 0. That's okay. One input, one output. Negative 2, 5. Negative 2, 5. That's also okay. One input, one output. And then we have 5, 10. One input, one output. But now we have 12 goes also to 10. 12 goes also to 10. And here it's still okay because each input has only one output. Even though 5 and 12, they have the same output. But remember, only from the input is the problem. One input, one output. One input, one output. For example, right, you have $1 and you put the dollar in the vending machine and you want a bottle of water. You get a bottle of water, right? You get a bottle of water. But then your friend comes also with $1. He puts the dollar in and he also wants a bottle of water. But it's totally okay because your friend is going to get a bottle of water, but only one bottle of water, right? So 10 represents the bottle of water. So this relation is a function. So this is a function. Because each of these inputs, they have exactly one output. And now let's look at the last problem for today. Describe the pattern in the mapping diagram, input and output y. So we have some of them already that are that have a match. So 1 and 4/3. That's the first order pair. And then the second order pair we have 2 and 5/3. 2 and 5/3. And then we have 3 and 2. But then we need to fill in these blanks, right? So let's take a look. What happened from 4/3 to get to 5/3? And then what happened from 5/3 to get to 2? On this side of the inputs, we know the pattern. Every time increases by 1. So it's +1, +1, +1, +1, +1, and +1. So we know here the inputs increase by 1. But let's take a look at the outputs. Let's find the pattern for these outputs, right? So let's take a look. We have 4/3. What did we do? Let's say how much we have to add to 4/3 to get to 5/3. So obviously the denominator should be the same, right? So it stays the same. So now what do I need to add to 4 to get to 5? And that's a 1. So the magic number is 1/3. And let's see if that is going to work. So we are going to add 1/3 each time. Let's see if it works from 5/3 to +2. So we have 5/3 plus 2 should equal, actually 5/3 plus 1/3. So 5/3, let's say if we add 1/3 to 5/3, let's see if we get 2 as the answer. Okay, so let's add the magic number 1/3. And let's see if we get to 2. And if we do that, that means that's going to be our pattern. 5 plus 1 becomes 6, right? So let's remove that 2 for now. And so let's see if we get a 2. So common denominator is 3. 3 stays on the bottom, and then we just have to add the top. 5 plus 1 is 6. And obviously 6 divided by 3 equals 2, so it works. So here it works, here it works. Plus 1/3, plus 1/3. And now let's continue that pattern. Let's add 2 plus 1/3. So 2 plus 1/3 equals, make sure we put a 1 under the 2. And now we need to find the common denominator, which is 3. We need to multiply 1 by 3. Whatever we do on the bottom, we do on the top. 3 times 2 is 6. 6 plus 1 is 7. So the next number is 7/3. And now let's add 7/3 plus 1/3 and see what we get. 7/3 plus 1/3. 3 is the denominator, and then 7 plus 1 is 8. So 8/3 is next number here in the blank. We have 2 more to go. So now let's add 8/3 plus 1/3. So from here we added 1/3. Let's add 8/3 plus 1/3 and see what we get. 3 is the common denominator, stays. 8 plus 1 is 9. And if we divide 9 by 3, we get 3. So the next number is just whole number 3. And finally, let's add 3 plus 1 over 3. Let's do it here. 3 plus 3 over 1 plus 1 over 3. Common denominator is 3. We need to multiply the first denominator here by 3. Whatever we do on the bottom, we do on the top. And then we multiply. 3 times 3 is 9. 9 plus 1 is 10. 10 over 3 is the last number there, right? So 3 goes to 2, and then 4 goes to 4 comma 7 over 3. And then we have 5, 8 over 3. And then we have 6, 3. And finally 7, 10 over 3. And we know that this relation is a function because for each input, there is exactly one output. Each input, one output. So this is a function. Okay? I hope you got a grasp how to identify patterns looking at a mapping diagram. Okay? So here we added 1 each time for the input, and for the output we added 1 over 3 each time. Thank you so much for watching, and again, don't forget to like and subscribe, and see you in the next video. All the best.